This lesson is the first where we start thinking about data structures and how to use them to solve problems. I will say that the further along we get into this class, the more important data structures become, and thinking about how you want to structure or solve the problem, you might want to use these data structures in order to help solve problems. It's a very big idea in the computer science world. I will also say that in mathematically, to solve these computational problems, that it's very important that you think about these ideas of data structures. Today's going to be a very simple one. We're either going to have I think a 2 by 27 matrix or a 27 by 2 matrix, but you can see just by which one you choose is a different implementation of how to solve it. So that's the idea for today. And we're gonna do data structure to solve problems. We're gonna solve the same problem that we talked about last time. A code word came out. We already know what it is. It's math rocks, of course, but we will decode that one today. So that's the idea there. And those are the two different data structures. And again, you want to think about those. So let's jump right into Python. So as you can see here, let me restart the kernel real quick. All right, everything's restarted. All my variables are restarted. So I'm going to start off with the same sort of situation that we had just a second ago, where alpha is this 27 vector, if you will, or list, I should say. So A through Z, and num alpha is a list with 5 through 27. So now what we're going to do is simply create this thing that I'm going to call a decode list. And it's going to be a list of lists, right? So that's the idea for today, is we understand and we are able to use a list of lists. So it's going to be alpha and num alpha. So if you did that, what would that look like? That's so alpha is a list, so that's the first row, and then num alpha is a list, so that's the second row, if you want to think of it in terms of like sort of like a matrix. So we can get the decode list up, and you can see the first row, or the index, 0 index, has all of the letters, and the second row, or the first index, has all of the numbers that's associated with it. So it's doing sort of what we wanted to do, but another way of looking at the same problem, another data structure, if you will, to solve the same problem would be if we wanted. So this is going to be a list comprehension. So I plus 5 and letter, or I comma letter in enumerate. I'm not sure if I've used enumerate in one of these yet. Let's say alpha. So alpha has all the letters in it, and let is going to be the thing. Okay, so that should work. F9. So it's another way. So now what you have is this row represents the letter A and its decoded value, B and its decoded value, and so on and so forth. So you see the difference between those two implementations. So now what we're going to do is we're going to go ahead and try to use, and we'll start off with this one. It doesn't matter which one we start off with. We'll start off with this one and see where we get. So code, so we got the numbers that come along with that, and now let's, the next thing that we want to do is this neat thing that Python does for you. If I want to take this code, which is a string, I want to turn it into a list. And one way of doing that is this split. And so you're going to need to use this split lots and lots during this course. So it's not a horrible thing to get introduced to it right now. And what this tells you to do is, so I want to split this string by the space character. And in other words, like 17, and then I'm going to split those two, and then it'll be a 5. And so it's going to create a list that has 17 and then comma 5 and then a comma 20. I mean, we could have done that. We could have just entered it by hand and put the commas in there, but Python gives us something that does that. And this ends up being something that we use a lot, because we do need to take these strings and turn them into lists so that we can analyze them. So you hit F9, and then we can pull up code, and we see that it's a string, so 17.5 and all that. So it's doing what we suspect. And now what we want to do is we're going to now go through each each one of these numbers in the list, like 17, and then we'll do 5, and then we'll do 24. But I got to take 17, and I got to look it up in my little numbers here, and then produce the letter that's associated with it. So let's start off by initializing what our word is. I don't know what it is, but we're going to find out. And then for C in code, what do we want to do? Well, I'm going to let IDX equal 0, because we need to step through, just by the implementation that we need to do with this data structure. I'm going to have to start it at the first one and then just keep going until I hit a 17. So that's how we're going to implement this. There may be a better way, but the way that we're going to do it right now is, so while, let's see, while C is not equal to decode underscore list, IDX, so row comma, right? So I'm stepping through the rows. So I start at 0, then I'll go to 1, then I'll go to 2, and then I need to look at the first. So if I pull up, pull up decode list again. So I want to look at the 0th one, right? So this IDX corresponds to the row that we're on. So it's row column, and then 0 corresponds to, am I looking at the 5 or do I want to look at the A? Well, it's gonna, that's C, right? These are numbers, and I'm trying to match that 17. So in other words, I'm trying to find this M here. So I need to step through this first column of this data, or the 0th column, if you will. And then, so while that's true, we want to increment IDX plus equals 1. Okay. One thing real quick. If I run this, it's probably not going to work, and the question is, take a second and think about why. Why would this not work right now? It's just not going to ever be equal to, or it's ever, while it's not equal, it'll just keep doing that, and eventually you'll run off the page. It'll never be equal to is the problem. And the reason is that this code is so if you were to look at code, so matter of fact, let's go pull it up. Code is a bunch of strings. So I need to typecast C into an int. So I'm comparing integers to integers. So let's make sure decode list, the second number is in fact, or the 0th number, the 0th column is in fact an integer. So that's what you want to make sure is they're the same, or it just won't do anything for you. And then once I've matched it, once I've reached, so for example, once I've reached the mth one, the 17th one, then I want to grab this thing and add it onto my word. So that's all we're going to do next, is I'm going to add, so this would be word plus equals to, so how would I get that out? It's decode lists, decode underscore list, and then IDX, because, oh no, we're gonna wait until we actually, so this while loop, we want it to keep going until that's true. So what happened is IDX was 0, wasn't true, 1 wasn't true, came all the way through here, all the way to 12, and then it was true. So then it X's out of the while loop, because that's true, because these two are equal to each other, and now I'm coming to here, and I want to now grab the M using that IDX that we just calculated. So that's, if I was inside there, it wouldn't, it would look kind of crazy. It'd be A, B, C, D, E, all the way, and it would skip M, right? So that's not what we wanted to do. What I wanted to do is find the index, which is 12, then exit out of the while loop, and then use that index in order to capture that M. Okay. So, oh, and then I got to tell it which column. So that's the row. So we know the row, and then the column is obviously the second one, or the Python oneth. I call it oneth instead of first, because first actually means the first one, and the oneth means in Python means actually the second row. And then if we do that, oh wait, yes, right. So we need to do the same thing that we did last time, where we just add a little space. So if you add a little space, and then when you're done with this for loop, we can just print word. Okay, so let's see what happens. And if you see what happens down here, it says math rocks, which is exactly what we encoded yesterday or last class. Okay, let's look at the other implementation, because I claim that maybe one of them might be more advantageous over the other one. This one's kind of clunky, and the reason why I say it's clunky is you have to do this little while loop here, which may or may not be obvious to you, but it's not horrible to do one of these every now and then. But I claim that this one might be a little bit easier for us. So let's see what happens. So decode list is now looks a little different. So now it's just 2 rows. So decode list looks like that, and I got to bring code up again and split it. So Control C, Control V. So F9. So now we're in a situation where I can now step through our word. So word is equal to, so initialize that one, and then for C in code, what am I going to do? Let's see, the first, all right, good. So when I hit enter and it didn't go to this indentation, this 4 space indentation, I get worried. I get worried that maybe I didn't close something out somewhere else. So, but since it did that, I can say C is equal to int C. So that'll be the first thing that I do instead of doing it all in one step like I did up there. So C is equal to int C. IDX is equal to decode underscore list. Now the question is, which row and column are we on, right? So go back up here to decode list, pull it up, and I'll put it to the side. And then I'm looking for, so this number 17, I'm trying to find the index of 17 into this second list. And I just turned it into a number, so it's the actual number 17. And so I need to index, so the row that I'm talking about is 1. So this will be 1 dot index, and then I'm going to throw in C. So think about what this is doing. So it's taking decode list, which is a list of a list, and I'm grabbing only the first row of that list. So the first row here, and then I'm indexing into that, and I'm passing in whatever letter, for example, 17 is going to go in there first. So it's going to grab this thing, and it's going to go find 17. It's going to pass me out 12. So that's what IDX is going to be equal to. And then I'm going to use that to simply go word plus equals decode underscore list. Now I have the number 12. So the first time through it's going to be 12. And now I want to use that 12. So now I'm going to come here. I'm going to go to the 12th one, and I'm going to get the M. So that is the 0th row. The 0th row in the IDX column. So the 0th row, grab that, and then go to the IDX column, the 12th column. Will give you the M. And then don't forget your space, or just be a bunch of letters all rolled up on top of each other. And then we'll print word. Okay, so let's run this code, find out what happens, and we get math rocks again. Okay, so again, to summarize sort of what we did here is, I think if I were going to program this, that I would rather do this. I would rather do this really clear index, give me the index, instead of doing this while loop in order to sort of funkily or kind of weirdly get to the index. I think this is a little bit more straightforward. And so it just mattered how I decided to structure my data, or data structure. And these things get way more important in the future. So just make sure that you've considered how you're going to create your data. You have decisions to make as a programmer. So that's the pretty cool part of it. But just make sure that you're doing it in a way that you think is going to, and again, you'll learn as you go through. You'll mess up a bunch of times, and that's fine. But as long as you do understand that data structures help you solve problems, then you can think of those along the way. Okay, that's all I got. Hopefully you learned a little bit on this one as well.